Hello everyone, hope you're having a great day and I welcome you all to this day 5 of AWS CV. Today's session is all about Elastic Block Storage or EBS. This session is going to be about storage service on AWS. So let's check the agenda for this session. In this session you will learn about what is EBS, different EBS volume types like general proposed SSD, provisioned SSD, throughput optimized HDD and cold storage. So that's all with the agenda. Now let's start the session. Before we begin, subscribe to Intellipaat and don't forget to press the bell icon to get more updates.
What is EBS? EBS stands for Elastic Block Store. Now, the purpose of the EBS is that you can assign a block level storage volumes with the instances. So your instances will need some storage to store some content to boot up the operating system from. So it needs some volume to be attached to the instance. Now, the thing is that these volumes are nothing but these are the virtual block stores that you attach to the instance, and it is connected to the instance in such a way that it remains a separate entity at the backend. Okay, so I'll just give you some overview on the slide itself, and I'll just switch to the presentation part. So it's what is EBS? It's a raw unformatted block level storage which is exposed as a raw device to the instance. Now it's an unformatted block level storage. Now block means that it is considered as a hard disk. If you see S3, it's an object-based storage, right? But it's a block-based storage. It's kind of a virtual hard disk that you send to the instance. Now EBS volumes persist independently from the instance, right? What do you mean by it persists independently? Persist independently means that if your instance is impacted somehow, it is terminated, then the performance of the volume is not impacted. Okay, let me just draw that example for you. So what exactly this thing is? What do you mean by the EBS volumes and snapshots, and what this thing is? See, let's imagine, I'll just give you one example so that you understand this concept. Let's assume that this is my EC2 instance. We already understood what is an EC2 instance. It's a virtual machine. Now, basically what happens is that you have to have this EC2 instance being attached to a volume. Now I've shown you that how a volume looks like whenever on the fourth step, you attach an EBS volume to it. Now what's an EBS volume? It's a block level storage. It's a block level storage attached to the instance. Okay, now the thing is that you attach the volume. So back and whenever you launch an instance, this volume would be it will attach itself to the instance, and automatically, if it's a root volume, it would be mounted. Fine. Now, there's one thing that you have to understand, that these two entities should be in the same availability zone so that they can be connected with each other. So they should be in the same data center. You can't have the instance in one availability zone where the volume is in a different availability zone. Fine. This volume is attached to the instances in such a way that if you as an administrator, this is for example your system administrator, you log into the instance from your end. For example, you initiate an SSH or RDP connection. You will find this instance you'll find this volume as the in-house storage. For example, it's a Windows instance. You will see that as a C drive or a D drive. Fine. So you might assume that, okay, this is the inbuilt storage of the instance, but the reality is completely opposite. The reality is completely opposite behind the scenes. The reality is that this instance may be running on for example, HP, IBM, or maybe a Dell physical server. It's running on a separate storage, and this volume can be running on this running on a separate server. This would be a part of a different storage infrastructure. So these are running on different platforms. So instead of running on a different physical server, the volume is a part of a different storage infrastructure. Now, this will enhance your capability to restore your data. See, the data of the volume and the image files. So the data plus your AMI files If it's a root volume, root means the main volume, it will be stored upon the instance. Now, there's a statement that we saw over there that the life cycle, the EBS volumes persist independently from the life cycle of the instance. What do you mean by that? Let's imagine this instance goes down, it terminates. Fine. Now, even in the events when your instance are being terminated, it's no longer can be reused, it crashes for some reason. You can have the volume stay over there. Okay, you can take this volume and link it to a separate instance, but in the same. So this is a separate instance or another instance, but you have to make sure that it is in the same availability zone where the volume resides. So you can detach it from one instance and attach it to the another one in a same availability zone. So you have that capability. So how this will prevent your data? Your data will be prevented in case of instance failure. If your instance crashes, it terminates, your data remains unaffected or safeguarded, because the life cycle of the volume stays independent from the life cycle of the instance, because they both run on a separate underlying hardware. I think you understand this point. So this is a very important fact you have to understand. I think now the next question that, okay, there's a question, what if the okay, NAS stand for network attached storage, SAN stand for storage attached network, DAS stand for disk attached storage. You can say that it's a storage servers. Just to make an example, these are the storage servers, storage infrastructure. Fine. Okay. Now the question is that this begs this question: what if the EBS volume goes down? See, one thing you have to understand: the EBS volume data is replicated across different places in a single availability zone. The data is automatically replicated, right? Automatically in a single data center. Apart from that, you can back up the volume in the form of snapshots. You have the capability to back up the volume in the form of snapshots. How you can do that? So for example, this is my EBS volume. Fine. Now you can back it up. You can back up using a concept called snapshot. Right? You back up the data in the form of snapshot. Now this snapshot data is being put into a backend Amazon S3 bucket that you can't see. It's a purely backend process being handled and managed by Amazon. So the data is being put to the Amazon S3 bucket. Now this is a pure backend process. You can't see that. This is not visible to you. It's a backend process. So you can see the volume, you can see the snapshot, but you can't see the bucket which consists of the snapshot data, right? EBS volume is replicated within an AZ, right? And the snapshot is replicated across different AZs in a region. The data of the snapshot is replicated across AZs in a region. So in these events, your data is being safeguarded because there are multiple applications going on. Your data is being duplicated in a single data center and across different regions, and your data is being safeguarded. Multiple copies of your data is being manufactured and synced in a single data center or across a region if you do that in the form of snapshots. Okay. Raw and unformatted data means that it's a raw data. Raw storage, raw disk attached to it with no data. It only has the image files with no data upon it. Unformatted, see, the thing is that basically what they say is that we attach a very new fresh volume to the instance with no data upon it. Okay, it's a fresh new volume. Fine. I think so the thing is that there's a cost for the snapshot, and the EBS volume. So they take that replication cost from the snapshot cost and the EBS volume cost. They will not charge you any extra for that. So they will charge you from the snapshot storage cost and the EBS volume cost. Okay. Now, snapshot stores across a region, across different availability zones in a region, within the region. For example, in a region there are 6 data centers, it will sync the data across all the AZs in a single region. Now, snapshots are called incremental backups. What do you mean by incremental backups? Now, can someone make a guess? What is an incremental backup? The snapshots are called incremental backups. What do you mean by incremental backups? Can this someone guess? It's an incremental backup strategy. What do you mean by this incremental backup strategy? So the thing is that the purpose of incremental backup is that only the new blocks of data would be put in the bucket every time you have the same snapshot of the same volume. Okay, let me just give you one example. Let's imagine that this is an EBS volume of 30 GB. Let me just give you guys already know the concept, but just to make sure that no one is left behind. See, let's imagine, I just give you one example over here. Just try to understand the example. See, whenever, for example, this is the original volume of 30 GB. Now, basically, it's a gigabyte. GIB is gigabyte. 1 gigabyte is equal to 1.07 gigabyte, right? Now, you have this original volume of this gigabyte, and you want to create a first snapshot out of it. You say, okay, let me have a first snapshot being created out of it. You will say, okay, this is my first snapshot. So this is your very first snapshot. Now, one thing you have to understand and you have to remember, the very first snapshot that you take from the volume itself, what it will do is that it will take the entire space in the backend S3 bucket. So it will say, okay, I will take the entire space in the backend Amazon S3 bucket. This is the S3 bucket. So in this case, it will consume the entire 30 gig of space, and you have to pay for it. You have to pay for every GB of data consumed in the backend S3 bucket, right? So in this case, 30 GB would be the one that you have to pay for. Now, let's suppose that you want to take the second snapshot of the same volume. So you say, okay, let me take the second snapshot. Now you take the second snapshot. So you're saying, okay, this is my second snapshot I want to take. Now you took the snapshot after a gap of 1 day. You took the snapshot after a gap of maybe 2 days. Let's suppose 2 days. Now, in the span of 2 days, only few blocks of data has been changed. Let's suppose in the span of these 2 days or these 2 snapshots, only 10 GB of data was changed. So in that case, snapshot 2 will append only 10 gigabyte of data. That's it. Similarly, if you take a third snapshot, so for example, you take the third snapshot of the same volume, it will add on, for example, between second and the third snapshot, only 5 gigabyte of data was changed or added. So it will just find those blocks of data that were changed or added and only add on that amount of data. Okay. Now you may ask this question, or this begs this question. Okay, in that case, what's the advantage you'll get? The first advantage you will get is that it will bring down the cost in terms of. So the very first advantage that you will get is that. Low storage cost comparatively, because instead of adding on 30 GB every time, it will only append the change data. So you have 30 plus 10, 40, 45. So in total, you just have to pay for 45 GB of storage, right? Also, faster backups. See, the thing is, the more data needs to be backed up, the more time it will take. 30 GB will take more time than 10 GB. 10 GB will take more time than 5 GB. So the more the data you need to back up, once you try to take a snapshot, the larger the snapshot, the more time it will take. So if you want to increment only changed data, only the blocks of volume that have changed, then only some amount of data would be added on. So it will result in faster backups and low storage cost overall. Okay. Now there's another part of the story. If you're able to retain the latest snapshot, so from the snapshot, you can also create a duplicate volume. So from the snapshot, what you can do is that you can manufacture duplicate volume, right? Now, so from the snapshot, you can store it to the duplicate volume. Now, if you're able to retain the latest snapshot and you carve out the volume out of it, it will encapsulate the data of that snapshot and all the previous snapshots. For example, you take the third snapshot and you're saying, okay, I want to extract a duplicate volume out of it. Now that volume would consist of the data of the third snapshot. If you're taking it from the third snapshot plus second plus first. So if you're able to retain the most latest snapshot and you carve out the volume out of it, it will capture the data of the third snapshot, the latest one, and all the previous ones. Now, sometimes some people ask this question: if I remove first snapshot and second snapshot, so will it impact? No. Will it change your cost? No, because at the back end the data is still saved in the S3 bucket. So even if you delete the first snapshot and the second snapshot, there will be no change in the terms of cost added to your bill. And if you're able to retain the third snapshot, you can, if you carve out the volume out of it, it will retain the data of that snapshot and the previous snapshots. You got the point? Okay, so this is the incremental backup strategy of the snapshot. Fine. Now, snapshots are used as incremental backups. Also, they are used. They are used for data migration and disaster recovery. They're used for data migration and disaster recovery. How? Let me show you. So they're used for data migration and disaster recovery. So let me do one thing. So for example, let's go to the AWS page, and so the thing is that let's imagine that this is, let me just go back to the services, and this is my EC2. Now let's imagine, okay, these are two instances running, primary instance and secondary instance. If I just go to the volumes, even you can see that on the instance page, I can see the volumes that are linked to these two instances. The ones that are in use are attached to a running instance, in use are attached to an instance. The ones that are available are not attached to an instance right now. Okay, so let me remove these free available volumes. Right now, let me show you. For example, I create a volume. Okay, now a volume is the availability zone specific resource. Now I'll discuss the volume types. Now these volume types will determine the performance of the volume. The volume types will determine the performance of the volume. It will decide upon the performance of the volume as such. Okay, we'll discuss them in detail. You define the gigabyte. I just make it as 5 gigabyte. Okay, now you have to choose the availability zone where that the volume would stay into. I choose US East 1A. That's it, and I can encrypt it. We'll discuss the encryption afterwards. I can add a tag to it. The tag is just the identifier. So I just name it as, for example, additional volume, right? That's it. And you can also extract it from a snapshot, but I'll not use snapshot as of now. Fine. Click on create volume, and your volume ID is created. This is a volume ID generated, and this is my volume. Now this volume, I can choose it, go to actions, and I can modify it. I can have a snapshot out of it, or I can attach it to, I click on attach volume and attach it to any instance in the same availability zone. I can do it without any issues, right? I can choose any of the instances in the same availability zone and attach to it. We'll not go with the attaching process as if now. So this volume, I just produce a snapshot out of it. So how will I go about doing that? I just go to the actions and click on create snapshot. Okay. Now, once I just click on create snapshot, it says that, okay, just put it in the description. I just name it as, for example, demo underscore snapshot. Fine. Now I can add a tag to it. Fine. Demo snapshot. So what I'm trying to do is that I'm just carving out a new snapshot from this volume. Click on create snapshot and the snapshot is created. Now, this snapshot is contained, is the data of that snapshot. It will take the entire 5 GB space and put into a backend S3 bucket that I can't see. Now, I can, if I just take the snapshot of the same volume, so only the incremental data would be backed up. Now there's no data being changed, so it will. If I just take the snapshot again, only 0 GB of data would be saved in the backend bucket. Now the snapshot is also used. So the very first thing is that it is used as an incremental backup strategy for the volume. Also, it is used for data migration. How? See, this snapshot, if you see over here, this snapshot is in region Virginia. I can take the snapshot and copy to a different region. So go to actions, click on copy, and I can copy it to, for example, let's suppose California. Okay, so I'm creating a copy of the snapshot from one region to another. I click on copy, and you will see that now, if I just go to California, switch to California, I'll be able to see the snapshot, the copied snapshot from Virginia to California. Can you see that? It just got copied over. Fine. So it is used for data migration, and also it is used for disaster recovery. So for example, if I lose access to the snapshot in Virginia, I can retain the same data from a duplicate snapshot in California. So also it is a disaster recovery and a data migration tool or a strategy. Okay. Now I can just go back to, for example, Virginia. Now you can't use a snapshot raw. You need to extract the volume out of it and attach it to the instance. So for example, I go to my snapshot, I go to actions, I click on create volume, and I can create a duplicate volume from the snapshot. So let me show you once again. I can choose the snapshot, go to actions, click on create volume, and I can choose a different availability zone this time and manufacture the volume in a different availability zone in the same region. Fine. So snapshots are used to back up the data of the volumes. They're used as incremental backup strategy. It's used for disaster recovery and data migration. You cannot pull the data raw from snapshot. It has to be extracted in the form of volume, right? Fine. If you want to retrieve that, because snapshot is just for the backups, not for data retrieval. If you want to retrieve the data, then you have to go for with the volumes, because snapshots are just in the case if you lose the volume, right? Snapshots are not used on daily basis. It's just for the backing up. Just in case if the volume crashes, you have the snapshot so that you can retain a duplicate volume out of it and retrieve your data. Fine. The data can be retrieved from volumes, but you back the volume in the form of snapshot, just in case if the volume crashes or it corrupts. Fine. You can also automate the process of snapshot creation. There's something called Lifecycle Manager. You can just go to Lifecycle Manager and you can automate the creation, retention, copy, and deletion of snapshots and AMIs. AMI process I will show you today itself. So it says create a new lifecycle policy, EBS snapshot policy. Click on next step. Okay, you just choose the volume. You can also go with the instance, but I will just go with the volume, and I can just start mentioning the resources over here. See, you can go with this one. Okay, you can type in the key. So this is the name, enter the value. So this is the additional volume, right? So this is the additional volume, and I want to back up. I want to create an automated snapshot at regular intervals, right? So I want to automate the snapshot creation process. So I can, this is a policy, just name it as, for example, automated snapshots. So I go to Lifecycle Manager on the left-hand side under this thing, snapshots, choose the volume, right? Put in the description. You don't have to change the role over here. Click on enabled, click on next. Okay, this is the volume ID, I think so. Hang on 1 second. So the tag is name, additional volume. So I'm choosing this tag only. Why it's not accepting it? Added this thing and click on next. Now it will ask me the frequency. This is schedule name, frequency daily. I can choose daily, weekly, monthly, yearly. So I picked the additional volume. I say daily, every 12 hours, starting at 9 a.m. as per the UTC time. Retention type count. You can keep the amount of snapshots and delete the previous one. So basically, you are scheduling the daily backup of this volume. For example, every 12 hours, you can choose frequency daily, weekly, monthly, yearly. You can create a custom cron job. So I'm saying that, okay, I want to back up this volume in the form of snapshot every 12 hours. And retain means that what's the count of last snapshots you want to retain. Let's make it as, for example, 5, right? And click on review policy and click on create policy. So it will just retain the 5 latest snapshots of this volume. Now, as per this policy, it will automatically create the automated backup in the form snapshot every 12 hours and retain the last 5 snapshots. So you can automate the snapshot process. There's another complicated way. I'm used to it, but this is the simplest way out there. You can use CloudWatch to automate the backups automatically. Okay. You can also share the snapshot with a different account as well. I can just go to the snapshot. I can choose a snapshot, go to actions and click on modify permissions. And I can define another root account number over here, click on add permission and share the snapshot with other root account owner. That I can also do. Okay, fine. That's about the volumes and snapshots. Let me discuss the volume types. See, these are different volume types based upon the performance that you expect from the instance. Because the thing is that upon the instance or the instances will be running a lot of workloads and applications to databases. Now you might have some different expectations. The first one is a general purpose SSD. Now, whenever you create any volume, you see that if I just go to the volume page and just try to carve out a volume, you will see that it gives me some different options out there to choose a different volume type. Can you see that? Now, what are these volume types? See, you have general purpose SSD. So what's the difference? See, general purpose SSD are mainly used in the cases in a wide variety of use cases, web applications, small database-based applications. Basically, it has the baseline performance of 3 IOPS per GB. Now, IOPS stand for input-output operations per second, which means that how many read and write operations can be carried on per minute. 3 IOPS, not per, I think it's 3 IOPS per second. IOPS stand for input-output operations per second, per gig. So these many read and write operations can be carried on per second. The minimum is 100 IOPS, and it can go up to 10,000 IOPS. I think now it is 18,000. Now it's just for general use cases. This is the SSD back storage, a fast storage. Provision IOPS is used now. The maximum that you get is 64,000 IOPS. It is the Ferrari of storage volumes. Gives you the fastest storage, fastest access to your data sets. Used for very large scale databases, MongoDB, Cassandra, DynamoDB, right? So if you have some transactions which are very fast in nature, then you use the provision SSD storage. It's the fastest of the entire lot. Throughput optimized HDD is used for long sequential workloads like data warehouses. Basically, it gives you 500 megabyte per second per volume of the throughput performance. Cold storage is used for cold data, gives you 250 megabyte per second of throughput performance per volume. And it's used to store the data which you don't access frequently. Okay. Generally, in your business environment, you'll be using either GP2 the most, but for high-scale databases, you go with the provisioned SSD, or at max, you'll use the throughput optimized HDD for data warehouses, for big data, for long sequential workloads where the transactions are not fast enough. Burst performance means that it has the top proof.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
See, baseline performance means this one. Burst performance is the topmost performance. So it says it can burst. So the baseline performance is 40. So let's suppose this is 40 and this is 250. So you can burst from 42 to 250, right? So baseline performance is the lower edge, lowest performance, and burst performance the topmost performance. So you can easily leverage from 40 to 250. There's a gap. Okay, so you can get the maximum performance. So burst performance is the maximum performance. It's the upper ground you hit. Okay, it's the upper ground that you hit. So burst performance is the maximum performance you can get out of it, and baseline performance is the least performance. Fine. So once you get access to the baseline performance, you can easily burst. Depending upon the write and read operations, it can easily burst up to 250 megabytes per second. Fine. So I've already discussed with you the snapshots as the incremental backup strategy. Lifecycle rules I've discussed with you. So that's about the stuff out. And the purpose of EC2 is that you can deploy a virtual server in the cloud. Now, what do you mean by virtual server? A virtual server is nothing but it is a kind of a virtual machine which has some compute capabilities, including GPUs, CPUs, RAM, storage. So it has all the compute resources with it, which are virtual in nature. Now, why you say virtual in nature? Because you can't see those physically. Now, whenever you deploy an EC2 instance, you deploy that virtual machine in a specific region, okay? And whenever you click on launch instance, so this is the EC2 dashboard. Some people call it as an instance dashboard. Yeah, this is the EC2 dashboard because instance dashboard is this one. If I just go, just see the instances. This entire thing is the EC2 dashboard. Now, once you just go to the EC2 dashboard and click on launch instances, the very first thing that you can see is that it gives you a couple of AMIs to choose from. Now, as we have discussed before, an Amazon machine image, it's a pre-configured template, which consists of all the scripts, software. The main thing is operating system, scripts, software, and application services that are encapsulated or packaged together in the form of an image. When you execute this image, all these things are installed upon the virtual machine. Right now, we discussed these that these are the quick start AMIs. I showed you the process that how you can manufacture a customized AMI. Right, I showed you the process. So the process is follows: you take a quick start AMI, right? Install everything upon it, capture the image out of it, and that image would show up under My AMIs section. Plain and simple, right? And marketplace, the marketplace is kind of, you can see that it's a SaaS concept, software as a service concept. You purchase softwares from these very esteemed vendors like SAP, Xent, Microsoft, Cisco, Juniper. There's so many vendors being there, or you can just explore them and you can just purchase their AMIs, or you can leverage these services in the form of softwares. And those softwares are in the form of AMIs, so the Amazon machine images. Community AMIs, most of them are free. It is just used for the experimentation or for lab purpose, right? Now, these are the public AMIs. For example, if I just go to any of my private AMIs, I can choose any one of them, right? And I can start launching my instance. For example, let me show you one thing. If I go back to the instance dashboard, and on the left-hand side, can you see that we have the images or AMIs? Now, these are my private AMIs, my customized AMIs. I can choose any one of them, go to actions and click on modify image permissions, right? So modify image permissions. See, the thing is that whenever you manufacture any Amazon machine image or AMI, it's private in nature. The customized AMI I'm talking about. Now, the thing is, if you make it public, public means that AMI would show up in the community AMIs page. Now, what is community AMI? If I just show you, if I just launch instance, on the left-hand side under community AMIs, it will show up. Okay. Now, you also have this image builder. The thing is that it's a new concept, still under, it's a kind of, we can see that it's not that much leaps and bounds compared to the AMIs or manufacturing the AMIs. If you go to EC2 image builder, basically the thing is that you have to put some inputs so that it can create a pipeline. Now, this is much more advanced in nature. So for example, I click on create image pipeline. Basically, it just creates a complete pipeline for the image to be manufactured, right? Now, it's a fairly new concept. From my experience perspective, it's not being used that much in a production environment. Basically, the main thing is that you have a complete pipeline to automate the image building process. Okay. How can we create community AMI? Whenever any private AMI, you make it as public, it shows up in community AMI. These are my private AMIs. I choose any one of these, go to actions, click on modify image permissions, choose public and click save, right? Once I click on save, it will take a few minutes and it will show up in the community AMIs section. It will show up in the community AMIs section. So any image that you manufacture, on the left-hand side, these are my own customized AMI, my private AMI. If I make it public, it shows up in community, right? Now, I just go to the instances, launch the instance, choose the AMI. Now, instance type is nothing but it's a virtual representation of the underlying physical resources, the amount of RAM, the CPU, storage, etc. Right? So basically, the main thing is that it's all up to you whether you want to choose any one of these AMIs depending upon the types of services and applications you want to deploy upon the instances. Now, the next thing that we'll do is that I click on next configure instance details. Now, we discussed that we can deploy the number of instances. I discussed with you 3 or 4 purchasing options: on demand, reserved, spot, and we also discussed dedicated host and dedicated instances. But the thing is that whenever you deploy an instance from scratch without buying any reserved instance, then it is on demand instance from scratch, or it's an on demand instance by default. Okay. Now, what is an on demand instance, by the way? The on demand instance is as per the requirement. Now, the on demand instance is the instance that you pay for the number of hours and seconds consumed. So, for example, you deploy an instance for, let's suppose, for 2 hours. Now, when there's no demand, you stop the instance, you pay 2-hour usage bill to Amazon Web Services, and that's it. You don't have to come into any long-term contract with AWS. So when you want, you get it. When you don't want it, dispose or you just get rid of it. That's it. You don't have any long-term contract with Amazon Web Services. Now, any organization that comes new or fresh on this platform, basically I've seen from my experience that for a few months they go on demand. Now, when they are pretty much confident, okay, they can just move forward and they can reserve those instances. It has 2 advantages. One advantage is that it will guarantee them the capacity whenever they want. For example, they reserve 1000 T3.micro instances. So they are being guaranteed that they will be allotted 1000 T3.micro instances for a duration of 1 year or 3-year contract. First one is the commitment. The second advantage is that they get 70% discount off compared to on-demand instance. Okay. So for example, an on-demand instance costs $1 an hour. It will cost you almost 30 to 35 cents per hour. Okay. So you get up to 70% discount compared to on-demand pricing model. Okay. So you go with the reserved instance, you're being guaranteed that the number of instances you will get based on the reservation that you have done, and also you get a discount. Now, we discuss the VPC and the subnets. VPC is nothing but it's a network where you deploy all your instances into, and each VPC will have a subnet. A subnet is nothing but it's a private IP address. Now, spot instances, it is rarely used in production environment. Basically, the thing is that you get 90% discount compared to the on-demand instance. But what happens in the spot instance is that you can't control the life cycle of the instance. For example, an instance costs $1 an hour. Now, if you do bidding and your bid is higher based on the trends, okay, let me show you one thing. See, for example, I go with, on the left side, I just go with spot requests. So for example, I go with this spot instance. I can request spot instances by choosing the specific configuration of the instance. But before that, what I can do is I can click on pricing history at the top right-hand corner. Can you see that? Now, the thing is, based on the specific availability zone, for example, let's go with instance types. I want to see that this is C3.8x large instance, which is quite costly. And I can see the trend over here in the past 3 months, for example, C3.large. And this on-demand price is this much, 10 cents. But if I go with spot, I do the bidding, this will cost me this much. So can you see that there's a very high much reduction in the, so it gives me up to 72% discount compared to the on-demand price. Sometimes you get up to 90% discount. Okay. Now, when you do the bidding, you have to put a high amount compared to what you're getting right now. Okay. Maybe $0.030. So you have to bid a high amount. When I've seen that there's a bidding of any property that's being done, they give you the minimum price. Okay, what's the price of this property? $1 million. This is the minimum price. Some will say, I'll give $1 million and $1,000 or $2 million. So you bid for that. Now, if your bid is accepted, so this is the minimum price. You have to bid higher than that. Now, once you bid even a cent higher than that, some chances are you'll get the instance. Okay. Now, the problem with this type of this spot pricing is that you can't control the life cycle of the instance. Now, you may ask me, what is life cycle? This means that when this instance will be stopped and terminated, you can't control it. That remote control is with Amazon Web Services. See, reserved instance and the on-demand instance, it's up to you. You can stop the instance, start the instance based on your requirement. But in this case, the instance will be terminated based on the Amazon Web Services need. So they will terminate the instance in 2 different scenarios. There's not enough capacity available. Maybe you have gone for 10 C3.large instances. You ran for 5 hours. Now, might be that after some time, someone has given a high bid than you, right? Or maybe there's not enough capacity available at the back end. So in that case, your instance would be terminated immediately. You can have some buffer time. You can buy some buffer time in that case. But the thing is that you don't have complete control upon the life cycle of the instance. It can be terminated automatically. You can see that on the dashboard, it will be terminated in the next few minutes. You'll be notified for that, about that. But you can't control its termination behavior. If any instance that's terminated automatically, this will hamper my production. Yes, that's the reason it's not very much used in production. It's used in universities. For example, you are a college student, and you're just building some AI and machine learning models. And you just want to, because there's already a tight budget, you just want to test the things out. The instance is terminated, that's okay. You're relaxed. There's nothing, your production environment is not inflicted in any case. Okay. Or for example, you're working for a media company like Netflix. Netflix uses spot instances for video processing, rendering. For example, the video needs to be consumed on Android devices, iOS devices, WebOS, or for example, on smart TVs. So it has to be converted into different formats. So there's some video rendering or processing needs to be done. So you can go with the spot instances, you process the videos, download them on your computer, and that's okay. So because video rendering or processing, it takes a lot of compute capacity. We click on XAT storage. Now we discuss in detail that this is the EBS volume, a block level volume that we attach to the instance. And we discuss the different volume types. Okay, we discussed the general purpose SSD. It's used for a variety of use cases for the web applications, for small scale databases. You don't have very high expectations, right? Provisioned IOPS. Provisioned IOPS is used in the cases where you need a very fast performance. It's a Ferrari of the volumes. It gives you up to 64,000 IOPS per GB of the volume. And it's used for very large scale databases like Cassandra, MongoDB, DynamoDB, etc. Click on Next Configured Security Group. Now we have discussed that in detail, that a security group is nothing but it's a firewall that you apply to the instance. Basically, you restrict the incoming and the outgoing traffic with respect to the instance. It's a firewall that you use. And then we review the options before we launch the instance. We launch the instance, we create a new key pair, which is a method of authentication, and we can barge in or log into the instance remotely. Okay. And I've already shown you that you can connect to the instance using different ways, depending upon whether it's a Windows instance or it's a Linux instance. Okay. So for example, let's go to EC2 pricing of the on-demand price. Spot instances are recommended for applications that have flexible start and end time structure. So as of now, our scope was very narrow. We were just focusing only one instance. Now we have to broaden our focus and go to an infrastructure which is based on multiple instances. See, your architecture will be dependent on multiple instances, not only one instance, because you need to achieve something called high availability of your applications.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job.
Now that we are done with the session, don't forget to subscribe to Intellipaat and press the bell icon to get the latest updates on Intellipaat.